In this video, we're going to discuss the reactions of hydrocarbons. And so alkanes, alkenes, and alkynes. Let us start with alkanes. Alkanes basically don't have reactivity. They have the very minimal reactivity. For the most part, you can burn them. And that's mostly what we do. Gasoline, natural gas, heating oil, things like that. These are all alkanes. We light them on fire, we warm ourselves up. That's not a very useful organic reaction, and for any other reason than warming, so we're going to move on to one of the few other things that it can do. Alkanes can halogenate. If you have propane, and you were to add a dihalide, like Cl2, what can happen is, well, there are hydrogens on that alkane. Chlorine can steal one of them. And so, well, it's a bit random. Let's just say this one. One chlorine will steal it, and the other will take its place. So you will end up with chloropropane. Now, it could be that you're in the middle, and there's no reason it has to stop at one. And so you could end up with multiple chlorines in different places. It's a very unexact reaction. Again, it's part of alkanes not being terribly useful, but it was a way to turn them into something functional. You can take an alkane, attach a halide, and then remove that halide with further reactions. And so it was a way to turn starting alkanes into something functional. Unfortunately, it means you have to have rather deadly chlorine gas. It was one of the first chemical weapons used in war. It is not friendly or safe. However, it is still used industrially because we do actually do a lot of reactions like this to small molecules. If you had something like ethane plus Cl2, well, as long as you don't add too much chlorine, you can reasonably be certain only one of them gets chlorinated. And as a result, you can make chloroethane, or 1-chloroethane. This is a good starting material for attaching ethyls to various things. And this tends to be one of the few uses we use alkanes for. Alkenes, on the other hand, these have a wide variety of reactions. Let's use this one. We'll say trans-2-butene, trans-but-2-ene. Alkenes can do several different things. First and foremost, we can hydrogenate. You can add H2. If you do this over a palladium catalyst, or a nickel or platinum, there's actually a lot of metals that this will work with, and you give it some heat, what will happen is you make an alkane. Those hydrogens have added to the carbons that used to have a double bond and replaced that double bond with another hydrogen. Now remember, they already had one. They still do. We simply have given a second hydrogen to each of those carbons, so they no longer have a double bond. This is a form of hydrogenation. Now, it might seem odd to destroy a nice functional group by turning it into an alkane, but we actually do this for food quite a lot. Unsaturated fats have double bonds. So if we want to turn a liquidy fat into something more solid, we can bubble hydrogen gas through a hot sample of the fat inside a container filled with nickel beads. What will happen is those hydrogens stick to the nickel, they attack the double bond, and they break it. So liquidy corn oil can be turned into something far more solid for our processed foods. If you're trying to make an energy bar, and you give it a liquid fat, it tends to be mushy. Think about a brownie versus a cookie. You use oil on brownies, but you use butter in cookies, and cookies have a much stronger form. And so by destroying some of the double bonds, we can in fact thicken that oil and turn it into more of a solid. So this is common in food products. If you see partially hydrogenated soy oil or partially hydrogenated any oil, that's what's going on. They're thickening it by removing some of the double bonds. So hydrogenation is one option. You can also hydration. So a little bit different. Hydration is adding water. If I have my alkene and water comes up, what can happen is the double bond can attack one of them, and the bond between them will attack the other carbon. The result of this is that you make new bonds, but instead of being to two separate hydrogens, you actually get a reaction that has an OH. So there were already hydrogens, again, on the alkene. They are still there. What we've done is we've added water. So hydration, hydrate, we added water. The result is that our double bond becomes an alcohol. And so an alkene plus water with a little bit of heat can become an alcohol. So hydration to an alkene produces alcohol. It synthesizes an alcohol. So there's a couple ways to describe it, but basically we turn it into an alcohol. So a double bond plus water can become an alcohol. So we can form more important functional groups that have a lot more versatility, like the alcohols, by adding water to a double bond. So we've added hydrogen, we've added water. There's a few other things we can add to a double bond. If I've got my butene again, and I add, let's do Br2, another dihalide. Well, they can do similar behavior, except in the alkane, it stole one hydrogen and then replaced that hydrogen with a halide. In a double bond, it just adds to both carbons. You might have noticed a trend here. Our things keep adding to both carbons. This is part of what's great with alkenes. You can add things to both carbons of that double bond. And so whether that's water to form an alcohol, hydrogen to form an alkane, dihalides to form dihalide alkanes, or our last one, similar mold, you can add an acid like HCl. So a halo acid, so HCl, HBr, HF, HI, will also add across the double bond. And so one of them will pick up a hydrogen, one of them will pick up that halide. And so double bonds have a large variety of reactions. These are some of the simpler organic reactions that double bonds will undertake. Your alkynes, they honestly can follow the exact same steps of alkenes. If I have 2-butyne and I was to add H2, I would get, well, hydrogens added. You would end up with but2ene. So one of the multiple bond would be removed. But we had triple bond, it goes down to a double. When I had a double, it went down to a single as I added those hydrogens. Now, you could do that if you still had some hydrogen around. It could keep reacting and eventually become an alkane. It's harder with alkynes to stop at this position you want, since it does the same reactivity as the thing it makes would do with its starting materials. Nonetheless, you can turn an alkyne into an alkene. You can even add halides to it. You can get alkenes with halides attached by using an alkyne plus a dihalide. You could try with water. Unfortunately, the alkene with an alcohol attached to the double bond undergoes its own reaction. So it's not a stable, or vinyl enols, as they are called, which would look like, so if you tried an alkyne plus water, you could make what's called a vinyl enol, but this is not stable. It would reorganize, it would become a double bond, and that hydrogen that used to be on the alcohol has moved and joined the other hydrogen that used to be on the other carbon. So this is not a stable route, and so we will not be discussing adding water to alkynes in any further depth than that. But an example of why you can't do every reaction. Sometimes the thing you make doesn't stay stable, and it goes on and does other things. But alkynes are good for these first two. You can turn them into alkenes, and you can even add halides to them. What we've seen here are three different functional groups. And what we saw was tools that we can use to convert one molecule to another molecule. Now we used a butene as an example for many things, but this applies to any other alkene. If I have just ethene and you were to add H2, it would become ethane. If I had propene and I was to add water, you would get propan-2-ol. Doesn't matter if you have a longer carbon chain or a shorter. This is showing us functional group changes. Really what I have seen here is that an alkene can become an alcohol, or up above, an alkene can become an alkane. These are conversion routes, individual tools that lets us make changes. Larger molecules, we can still target that functional group and do that change. And we'll explore that more when we get to how to make syntheses. But that is the general idea of hydrocarbon functional groups and their easily done reactions to convert them to other functional groups.